Okay, so in this lecture, I'm going to start section 7.3, not finish it. So we're going to focus in on formula mass and molar masses and converting between molar mass to mass in grams to moles, and then eventually to atoms or molecules. So just a lot of conversions going on in this section. So chemical formula is a combination of chemical symbols, and the numbers represent how much you have of each of those types of atoms. So just by looking at a chemical formula, you can figure out the elements present in that compound as well as the relative number of atoms and ions in it. Just from the chemical formula, you can figure out the formula mass, the molar mass, and then in a different lecture, the percentage composition.
Does he still have that money tie?
Yeah.
Awesome. Smith. No, Smith. I did. Damn, not the sprays.
We'll discuss that another day. Moving on. Okay, so first up, formula mass. The sum of the average atomic masses of all the atoms represented in the formula for any molecule, formula unit, or ion. So if I wanted to know what the formula mass of H2O, water, you'd use the periodic table. On my big periodic table, it would be the pink numbers, but the average atomic mass of hydrogen is 1.01 AMUs, but I have two of them, so I'd multiply 1.01 times 2. And then the average atomic mass of oxygen, on mine it says 15.99, but depending on the periodic table that you use, it might just round up to 16. So then you'd add them up. So 16 AMUs plus 2.02 AMUs, you get 18.02 AMUs. So the formula mass of H2O would be 18.02 AMUs. Just ignore that. I don't know why that line is there. So it's nothing special. Okay, so remember with a molecule, the term molecule means that it's a covalent bond. There's some covalent bonds there. So if you see the term molecular mass, like what's the molecular mass of H2O, I just want to know what's the weight of it. So you do this. Or the formula unit. What's the formula unit of NaCl? Well, then I'd find sodium 22.99 and then chlorine 35.45, and I'd add them up and then just make sure you stick AMU or U at the end. So those are your units for this. Also, significant figures back in the play here with math, right? So we are adding, and yeah.
It's like the smallest ones.
Yeah.
If there's 3, don't go to 3.
Yeah.
Unless it's stuff strands.
Yeah. Okay, we're going to see if this link works. Nope, doesn't look like it's going to work. Okay, I'm just going to move on. Okay, sample problem. Find the formula mass of potassium chlorate. So I'm going to get my pen here. So just break it down. Okay, I got a K. That's potassium. K equals
39.1.
39.9? Yeah, I think you're right.
It says 1, like 39.1.
39.1.
Let's see, yay. And then there's.
I'm going to say 1. I'm just going to go 0.10.
Okay.
All right, chlorine, 35.45.
30, yeah.
I have that one memorized.
And then 3 oxygen. Right.
Yep, so then oxygen, there's 3 of them. So I'm going to say 3 times
15.99.
15.99.
You're not going to use all the lines.
No, I'm just going to stop at 99. All right. So I got my calculator all ready to go here. 39.10 plus 35.45 plus times 15.99.
I have 122.52.
That's what I got. And the units, AMU, or you can just write U. Or U. Yep. Well, because we're adding them, so then you just go where the last common number is. So 2. Now, like when you look at your periodic table, maybe just always just go to 2 decimal places.
Right.
You know what I mean? And you'll be fine.
So CA is calcium.
Yeah.
40.8.
Okay, so now moving on to calcium nitrates. So I have calcium, 40.08. If you remember my calcium rap on YouTube, check it out.
No promotions.
No promotions there. Okay, that's really bad, 40.08. Okay, so then I got nitrogen, and you notice that it's in parentheses. So you gotta distribute that to everything inside. 2 times 14.01.
And there's going to be 6 oxygen.
Okay, multiplication signs. Yep.
14.01.
All right, punch this into my calculator.
Can't see those pink numbers up there?
164.
Yep, 164.04. Some of them are darker red, and some have faded to be pink.
Oh, we still have the crosses through the elements we did on that project.
Yep. All right, so 164.04. Yeah, okay. So a while ago, at the beginning of the school year, we discussed the mole, all right? Where the 1 mole is equivalent to 6.022 times 10 to the 23rd particles.
Avogadro.
Also Avogadro's constant. So let's just see if if this works. Doesn't look like it's gonna work. Okay, well,
That's fine.
what a disappointment.
I wanted to be yellow.
Oh, cool. That didn't even go into. So sorry. Okay, just stop. Oh, jeez, 0.8. What the heck? There we go. Okay, so the molar mass is the definition. It's the mass in grams of 1 mole, or approximately 6.022 times 10 to the 23rd particles of a substance. So the molar mass of calcium on the periodic table is 40.08 grams per mole. That means if I said, hey, measure out a mole of calcium, you would just measure out 40.08 grams of calcium. So 40.08 grams of calcium equals Avogadro's constant. That means in that sample, 40.08 grams of calcium, you have 6.022 times 10 to the 23rd atoms in that sample. Okay?
Okay. So you're saying like the Rent unit's like 260.
Mm-hmm.
So
If you measure out.
1 mole would be 26 grams.
Mm-hmm. Yep.
Stop it.
Okay, so the molar mass has a different unit, okay? It's grams per mole. So you can figure out the molar mass of an element just by using the periodic table, but you can also figure out the molar mass of a compound, kind of like what we just did on the previous slide. The only thing that's different is the unit. That's it.
Oh.
Okay, so if it says, what's the molar mass? Your unit is grams per mole.
Instead of AMU.
Correct.
So it's the same exact answer.
Yes. Okay. So the compound's molar mass is numerically equal to its formula mass, but
We're just using a different.
just a different unit. So going back to that molar mass of H2O, I again use the periodic table. Yep, 1.01 grams per mole. I have 2 of them. And the average atomic mass of oxygen is,
It's in hydrate 0.
no, well, that 8 at the end, it rounds to 1.01. So again, dependent on the periodic table that you use, your numbers might be different from mine. So when I grade these, I'm really just looking for ballpark numbers. Really, I am. So anyways, you add these up, so you get 18.02 grams per mole, and that is the molar mass of a water molecule. All right, I don't have any faith in this link, but you never know.
Nope.
Disappointment again. Flash, I just missed Flash. All right, so there's this figure in your book that looks at, formula unit of zinc chloride, just showing you how they get that. Zinc sulfate, ammonium sulfate, but then, yeah, I'm just gonna move on. Okay, what is the molar mass of barium nitrate?
And then there's going to be 2 nitrogen.
How much is nitrogen?
14.01. And 6 oxygen. 15.99.
All right, handy dandy calculator.
361.26.
Yep, that's what I got.
261.
Yep. Grams per mole. Wow, don't we do conversions in this too?
Eventually.
Oh, no.
All right. Any questions about the molar mass?
Nice easy.
All right, so the molar mass serves as the conversion factor. You can go from moles to grams, grams to moles. So sample problem, what is the mass in grams of 2.5 moles of oxygen gas? So first off, what is oxygen gas?
O2.
O2, okay.
Well,
All right,
2.5.
so using, what we got here, we're going to take the amount in moles, that's the given, 2.5, 0.
Smaller mass. Well, it would be squared, or
Yep. The molar mass of oxygen. So we got to figure out the molar mass of oxygen. And oxygen gas is O2, so
is it 31.98?
2 times 15.99.
31.98.
Yeah.
This is the 30.
What? If you just put 30, that's incorrect. 31.98.
times
Okay.
79.95.
Okay. So I'm going to show you the actual conversion factor so the units cancel.
Is it over
because you might be doing 2-step conversions or 3-step conversions. We've done this before.
Wouldn't it
Okay.
be over 1 mole?
So I'm in moles, right? So that means 1 mole goes on the bottom,
And
1 mole of O2. And then the molar mass of O2 is what we just calculated. I don't know why I put that 1 there. It's supposed to be 31.98 grams. Okay.
the moles cancel.
So the moles cancel out, and you just multiply and divide across to get your answer. 2.5 times 31.98 divided by 1. 79.95. And the answer is just grams. Okay, but are we really done?
No.
No.
Yeah.
No, we're
Grams
not.
to moles.
No.
Grams of oxygen. Grams of O2.
We have
Sig
grams.
figs. How about
Sig figs.
So it's at 79.
How many sig figs here?
2, 3.
No.
Well, 2, right?
73.
2.
I think it's 3.
You guys don't remember your sig. It's 3.
Yeah, because there's a 0 at the end.
So it's 80.0?
80.0.
Yeah.
Well, I was saying 3 and she wasn't saying anything. So I was like, oh, it's 2. I don't know.
It's making you feel
So what
unsure.
would it be? What would we say, like grams of O2?
No.
Grams is good enough for me. If you want to be specific, you could say grams of O2. It doesn't matter. But grams is good enough for me. Whoa. Okay, we can also go from grams to moles, which means you're going to divide the amount in grams by its molar mass. So how many moles are in 252.1 grams of iron 2 chloride, which is FeCl2? So maybe we should figure out the molar mass of FeCl2, right? 55.85.
How do you know that?
I have it memorized.
That's impressive.
How was chlorine?
35.45.
What is 10?
I don't know. I don't use tin a lot.
10 is a loser.
118.2.
I'll tell you 10
That's a
right
7.
now, dude.
All right, and then I got chlorine. I got 2 of them at 35.45.
What's that? 70?
126.775. You already have that.
Make sure I'm right. I'm getting there. Okay.
59.
126.75.
Yep.
Okay.
Quick math.
All right, grams per mole. All right, now we can go to the problem here. So start with what you're given, 252.1 grams. Set up my conversion factor. What's gonna go to the bottom? Yeah, the 126.75 grams.
And 1 mole on top.
1 mole on top.
So then we just divide.
2 point something.
1.9889.
Okay, how many? 4 sig figs, very good. There's 4 here, and there's 5, so you go to 4.
1.989.
1.989, yep.
And it's just
And then it's smalls. Yeah.
Yep.
very good.
Oh, we have to do some ibuprofen.
I hated these 2 steps.
Okay.
I just figured out.
Moles of particle.
Yep. So just be aware that if it's asking for, like, if you're dealing with a compound, you know, like, for example, if I had H2O, right? If I had a question that said, how many moles of hydrogen do I have, what would you say?
6.022.
2.
2. How'd you get that, Nathan?
Because there's
He
just.
guessed.
Because there's 2
Because you're
hydrogens.
It's just
having
2.
one of each. So
Yeah, one of each. Yep.
Yeah.
Yep. Okay, and if I said how many moles of oxygen are in a molecule of what, then you'd say 1. Okay. So, okay, so we can also go to the other side, converting between moles and number of particles, and this is where we're going to use Avogadro's number.
I got a feeling on the worksheet there's going to be 2-step conversions.
Oh, yep, definitely. Three.
Perhaps.
So, moles to particles, if you want to go from moles to particles, you will be multiplying the amount of moles by Avogadro's, and if you're going from particles to moles, then you're going to divide by Avogadro's. Okay, so here I have a sample problem of ibuprofen. C13H18O2 is the active ingredient in many non-prescription pain relievers.
Wait, that looks like a polyatomic.
It's not, because there'd be a charge.
Yeah.
Okay, so this is covalent. If the tablets in a bottle contain a total of 33 grams of ibuprofen, how many moles of ibuprofen are in the bottle? How many molecules are in the bottle? And what's the total mass in grams of carbon in just 33 grams of ibuprofen? Holy smokes. So what's the first thing that we probably need to figure out before we do anything with A, B, and C?
Molar mass.
Find the molar mass of ibuprofen.
So carbon, 13 carbon.
I'm going to type.
12.01.
Yep.
And 18 hydrogen, which is 1 and 2 grams of oxygen, 2 oxygen, which is 15. Alright.
Calculator, I'll be back.
Yep.
Oh, it's 206
Whoa.
in my head. 206 point.
I have 1 6.
Do the math. You got to do it.
All right, I'll retype. I got 2.9, but maybe I just typed it wrong, so I'll just redo it.
Okay, maybe it's.
Oh, I messed up
I'm
mine.
recalculating in my head. Maybe it's not 206.
I did 156 instead of
I'm gonna make
156.13.
an observation that Mrs. Z is probably right.
Yeah.
I think
I,
there's
I,
206
she
wrong.
is, yeah.
Just a wild guess.
Yeah, just by
Wow.
chance.
Yeah. you're right.
Yeah, 2.9.
That's what I got in my head.
2.9. Okay,
Yeah.
0.29 there.
Yeah,
Okay.
I got that in my head too.
Great,
I forgot the 1 3 at the end of 156.
Grams per mole. All right, so looking at A, if the tablets in a bottle contain 33 grams, how many moles of ibuprofen are in the bottle? So how am I going to solve A?
So 33
So start with what you're given, 33 grams.
So we times it by moles.
times.
No.
What are we trying to get to?
Moles.
Moles, right?
So it'll be 1 mole on top.
Yeah, 1 mole on top.
And then 206.29.
Yep.
So you have
So we're going to divide by the molar mass to get 2 moles. So you're going to stick 206.29 on the bottom.
0.0145. But there's sig figs.
Yep, so
it'll be like 0.01.
2 sig figs.
2?
0.01.
That would be 5.
All right, so I get 0.159968975. So we want to go to 2 sig figs. So it's going to be 0.16.
Yeah.
And my unit is moles.
Right, the bottle, so we times it by 30.
How many molecules of ibuprofen are in the
So
bottle?
we have to do something with Avogadro's.
We've got to do something with Avogadro's.
So for moles, you got to take the mole number and times it by Avogadro.
Yep, that is the only way you can get to atoms. You have to somehow use moles. So we're going to take the number of moles we have and multiply by Avogadro's.
0.002 and this would be 1
At least one.
No, it'd be 0.16.
Oops.
I'm gonna guess it's gonna be a pretty big number.
I'm guessing it's at least.
It's gonna be at least the 20.
It's gonna be over
It's gonna,
1.
it's
At
gonna be
least
at
one.
least the 20. Like 9.6 times 10 to 26. Actually, yeah, might be right. Maybe over 15.
Is it 23rd, right?
Gosh.
10, 23rd.
Yeah. 9.6352 e to 27.
Molecule.
Smart video.
So like a lot.
All right, here we go.
I think I did that right. Huh?
Okay, 9.6352 times 10 to the 22.
Yep.
Okay, how many sig figs we got?
2.
2. So 9.6 times 10 to the 22.
And that's what's
Wait, didn't we already get the mass of carbon? No?
Technically,
have
you
that?
want to say molecules. I wouldn't mark it wrong, but because atoms means like you're just dealing with one element. And here we have carbon, hydrogen, and oxygen. So molecules would be the appropriate units.
Did we already figure out C though?
Okay, C. What is the total mass in grams of carbon in 33 grams of ibuprofen? How do we figure that out?
It's 13.12.01, right?
13, what?
13 times 12.01. Like, didn't we already figure that out to get to the first part of things?
Wouldn't it be 33 grams?
No, it's not 33 grams.
Your carbon mass times your mole.
Yeah,
33 times.
hold on. I have to think about this.
No, because didn't
It's got-
we- then we
Because
add
this
them
is
all
this is
up.
13 moles. 13, like if I asked you how many moles of carbon, you'd say 13 moles.
Mhm.
But then we want to figure out the total mass of it. So we go moles to grams and then divide somewhere in there.
Okay, so
Yep.
like, to get the first step for A, right? We got 206.29 grams. By using 13 times the 12.01.
Okay.
Can't we just shortcut it and use the 13.12.01 since we already found out that information?
Probably.
Aren't you gonna use that 0.16 number?
Somehow. You
Like
know what? I should have
156
done this before you guys came to class. You know, I only do this chapter how many times a year, right? You'd think I'd have it memorized by now. Very embarrassing. Sorry. For those that are watching my video.
They come, they
I was back 20 bucks.
Okay, to find the total mass of carbon present in ibuprofen, the two conversion factors needed are the amount of carbon in moles per mole of C13H18O2 and the molar mass of carbon. So, we are going to take 13 moles of carbon multiplied by the molar mass of carbon.
Times the mole is what?
So we're going to take the mole, sorry, I'm going to start over. The amount of moles we have in ibuprofen, which is what?
13.
The amount.
13.
0.16. The amount of
Oh, yeah,
moles,
yeah, yeah.
yep. So 0.16
So
moles
will be on
of ibuprofen.
the bottom, and then it will be the mass of.
Yep. And then 1 mole of ibuprofen. Oh God, this is gonna get so messy. All right, I'm just gonna write it all out. C13, H18. That's an 18. O2. All right, so they want to know how carbon, right? So how many moles of carbon do I have in ibuprofen? 13. So you put 13 moles here.
Huh?
Yep. And then what's the molar mass of carbon?
Yeah.
Yep. So 1 mole goes on the bottom, so the units cancel out. And then 12.01.
Okay, so you
grams on top.
You times 12
Yep.
so it's like 0.0.
So, if you were to rewind this, I said, okay, yeah, we got to do something with the amount of moles in ibuprofen. There's my 13. Multiply by the molar mass, and then eventually get to, so I kind of did it backwards in my head.
So it's like 24.18.
Yep, so I'm going to type it in 0.16 times 13 times 12.01. Yep, so I get 24.9808, and then we have two
Two sig
sig
figs.
figs, so
So
25.
that'd just be grams.
Yep.
Yeah.
Okay, so exactly what does this mean? Well, I have 33 grams of ibuprofen, and just take a look at the chemical formula. 13 carbon. Well, the molar mass of carbon, is 12.01. So like the majority of the substance is mostly carbon. I mean, even though there's more hydrogen, the molar mass of hydrogen is really low.
18.18.
Okay, so that's what that means there is if we just figured out the amount of carbon in this sample. Kind of cool, actually.
Oh, no percentage.
Okay, that's it. I'm just gonna stop that right there.
Yep.